Objective 1 for the Topic 9 study guide says be able to deduce the oxidation number or oxidation state for each species in an equation. Then it reminds you you'll have to know the 7 rules and their priority. And the way I keep track of it is this mnemonic 1, 2, Fehockel, or however you want to say it. But that reminds me that the 1A elements get to be plus 1, 2A gets to be plus 2. Fluorine is always minus 1. Those 3 never change. There's nothing that can force any of those elements to take on a different oxidation state. Oxygen then will be a minus 2 unless it's with fluorine or with itself, then it's forced to take on, in the case of fluorine, it would have to take on a plus 1, and when it's with itself, it takes on a minus 1 charge, and we call that a peroxide. And then hydrogen takes on a plus 1, except if it ends up with a 1A or 2A metal, then it takes on the minus charge. And this really isn't so strange because, again, you're just talking about the control of the electrons. If fluorine and oxygen bond, fluorine's going to take more control of the electrons and oxygen's going to lose control of its electrons. And when hydrogen typically bonds with a nonmetal, it gives up control of its electron as it's sharing unequally. But with a metal, it would take control of the electron because metals don't want the control of the electron. And so then the last one is chlorine, and chlorine will take on a minus 1. Again, unless it's with hydrogen or oxygen or fluorine, and those force it to take on a different oxidation number. For example, oxygen can force chlorine to become positive or give up control, whereas fluorine can also. So then when you're looking at something like H2SO4, you assign the oxidation state in order. So oxygen gets to be minus 2 and hydrogen gets to be plus 1, and sulfur has to take the leftovers. So I know the oxygen is going to have a total minus 8 charge, the hydrogen is going to have a total plus 2 charge, and overall this compound has no charge. So that means for this to work out, sulfur must be a positive 6. If it was something like dichromate, Cr2O7, which has a minus 2 charge overall, I would still assign oxygen the minus 2 for a total minus 14. But now instead of adding up to 0, this adds up to minus 2. So now the charge on chromium has to be a total charge of plus 12 for 2 different chromium, or each chromium is a plus 6 charge. So those are the rules for assigning oxidation states.